welcome to our channel Knowledge of Friends. Subscribe to the channel and click the bell icon for the latest update. Today we're going to start with your CBNST class, that has been the computer based numerical and statistical technique, and that has been the classes 29. We had done 28 classes in the last session, even though we had started with unit 1, which has been the computer arithmetic errors and rules of equation, and in that we had done second method, bisection method, and many more we had done. After talking about that, unit 2 we have to cover up the interpolations and the curve fitting, that what we have started with, and in that we have done many of the questions related to it. And but today we have to start discussing about the question, because in the last classes I had told you about the finite differences operator, and where we had done your shift operator, forward difference operator, backward differences operator, central differences operator, averaging operator as well, that I had told you with the symbols and their formulas as well. If you had not visited, you can go ahead last previous video, so you can go ahead, you will find it out all the videos there. So here we'll go ahead starting with first of all, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many maximum people can get the information at once, and even though you can also enjoy the video as well. So here we go ahead. The question we have: proof forward operator equals to e minus 1 and forward operator equals to 1 minus e की power minus 1, that is the inverse. So we know that forward operator fx equals to fx plus h minus fxh equals to e fx minus fx, where e fx equals to fx plus h, and that will get your value here e minus 1 fx. So comparing the operator of fx on the both side, we'll get delta equals to e minus 1 or e equals to 1 plus delta. Consider fx equals to fx minus fx minus h, which is equals to fx minus e minus 1 fx. So for the same here, e inverse fx equals to fxn minus h. Comparing the operator of fx on the both side, we get backward operator equals to 1 minus e inverse equals to 1 minus backward operator. Now we go ahead for the next question that we'll have to discuss here. Proof e n fx equals to fx plus nh, e n minus n fx equals to x minus nh. That what we'll have to discuss here. So we go ahead for the same, and that is being the value we get considered efx equals to fx plus h. In this expression you have to replace the x by x plus h. Fx plus h equals to fx plus h plus h. Fx plus h equals to fx plus 2h. From equation 1 we know that fx plus h equals to efx. Put the value of x plus h in the above equation, so we get here efx equals to fx plus 2h, e square fx equals to fx plus 2h. Again replace x by x plus h, e square fx plus h equals to fx plus h plus 2h, e square E fx equals to fx plus h. E fx plus h minus E fx, and that will give you E cube fx equals to fx plus 3h that we get here. Okay, this is your 3h as well. So the generated form of the equation we get En fx equals to fx plus nh, and for the same similarly E inverse fx equals to fx minus h, and on the same case we go ahead further, which we'll talk about it further, and we'll find out the value here, which will be E inverse square fx equals to fx minus h, x minus 2h, and for generating this equation we get E minus 1 fx equals to fx minus nh. Now we go ahead for the next question. Prove equals to E 1 by 2 minus E minus 1 by 2, and your u equals to, and that has been half E 1 by 2 plus E minus 1 by 2. So from the equation here, E o of n fx equals to fx plus nh. From the definitions of the central differences equation that been given here for the equation, which we'll get here, fx equals to fx plus h by 2 minus fx minus h by 2. For the same, fx equals to fx plus 1 by 2h minus fx minus 1 by 2h, and which is equals to E 1 by 2 fx minus E minus 1 by 2 fx. It will give you E 1 by 2 minus E minus 1 by 2 fx. For comparing the operator fx on the both side, we get equals to E 1 by 2 minus E minus 1 by 2. From the definition of averaging here is you get fx equals to fx plus h by 2 plus fx minus h by 2 upon 2 equals to 1 by 2 fx plus 1 m by 2h plus fx minus 1 by 2h. So we are half E 1 by 2 fx plus E minus 1 by 2 fx equals to half E 1 by 2 plus E minus 1 by 2 fx. So comparing the operator of fx on the both side, we get equals to 1 by 2 E 1 by 2 plus E minus 1 by 2. We go ahead further, which we'll talk about it, and that has been the another question here, that what we'll have to discuss as well. So here, prove tilt equals to 1 by 2 forward plus backward difference operator. So here we multiply this and we'll get the question which is in the form of mu s is equals to 1 by 2 E 1 by 2 plus E minus 1 by 2 E 1 by 2 minus E minus 1 by 2 minus 1 by 2, e minus 1 by 2. So from the equation we get e minus 1 equals to 1 minus backward. From the equation we get here e equals to 1 plus forward. Putting the values of e and e inverse in the following equation, we get mu equals to 1 by 2, 1 plus delta minus 1 minus backward equals to 1 by 2 forward plus backward. So further it will be, that will be giving you is as s equals to 1 by 2 forward plus backward. We'll go ahead for the next question. That has been the another important question here. Proof equals to e 1 by 2 backward equals to e minus 1 by 2 forward. From the equation here we know that equals to e 1 by 2 minus e minus 1 by 2 equals to e 1 by 2 minus e inverse, that is being equals to e 1 by 2 backward, where we can say that e inverse is equals to 1 minus backward. So equals to e 1 by 2 minus e minus 1 by 2, that is being equals to e minus 1 by 2 e minus 1. By taking e minus 1 by 2 common and get e minus 1 by 2, and always that is being forward equals to e minus 1. So equals to e 1 by 2 backward equals to e 1 minus 1 by 2 forward. We go ahead further, which will be having another equation. Another question here is your proof e inverse equals to 1 and square equals to backward and forward. So by the definition we get here e fx equals to fx plus h. In this expression we'll replace x by x minus h, then we get here is your e fx minus h equals to fx minus h plus h. That will give you e fx minus h equals to fx. From the equation that we get e inverse fx equals to fx minus h, putting the value of fx minus h in the above equation, we get e inverse fx equals to fx. So comparing the operator of fx on the both sided, so what we'll get here, that what we'll have to find it out here, and which is being your e inverse equals to 1. Putting the equation, we know that e 1 by 2 backward, which is further equals to e minus 1 by 2 forward. Multiplying the above two equation, we get here equals to e 1 by 2 backward into e minus 1 by 2 forward, which is equals to backward into forward, and square equals to backward into forward. Now we go ahead for the next question that we talk about it, which has been the important one, of course. And so for that we'll go ahead. Another question. Prove 1 plus delta forward 1 minus backward equals to 1. So from this we get here e equals to 1 plus forward and e inverse is equals to 1 minus backward. Multiplying these two equations, we get e into e inverse equals to 1 plus forward and 1 minus backward. So e inverse equals to 1 1 1 plus forward and 1 minus backward equals to 1. Then there's 1 plus forward and 1 minus backward is equals to 1. Now we go ahead for the next question. We talk about it, which is being the important one. That is being the another important question is to prove backwards inverse forward equals to backward inverse backward equals to 1. So putting the definitions of forward difference operator and the equation we get here is forward fx equals to fx plus h minus fx. Here fx equals to forward inverse fx plus h minus fx, where fx plus h equals to e fx. From the equation we can write the above equation here, which will be in the form of fx equals to forward inverse e fx minus fx equals to forward inverse e minus 1 fx that we have. So comparing the operator of fx on the both side, forward inverse e minus 1 and forward inverse forward equals to 1, where e minus 1 equals to forward. So forward inverse forward equals to 1 and backward inverse backward equals to 1. You will have to prove about the relation, you have to start from the equation that we had done is your backward fx equals to fx minus h, to follow the same procedure that we have. Now we go ahead for the another question, that is being proof mu square equals to 1 plus square upon 4. So from this equation we know that we put the value equals to 1 by 2 e 1 by 2 plus e minus 1 by 2 equals to mu square equals to mu into mu equals to 1 by 2 e 1 by 2 plus e minus 1 by 2 multiply 1 by 2 e 1 by 2 plus e minus 1 by 2 equals to 1 by 4 e plus 2 e 1 by 2 e minus 1 by 2 plus e inverse, which is equals to 1 by 4 e plus 2 plus e inverse. So we go ahead for mu square, we can write the equation 1 by 4 e plus e inverse plus 2 equals to 1 by 4 e plus e inverse plus 1 by 2. So from that equation we get equals to e 1 by 2 minus e minus 1 by 2 square equals to into equals to e 1 by 2 minus e 1 minus 1 by 2 into e 1 by 2 minus e minus 1 by 2 equals to e minus 2 e in half e minus 1 by 2 plus e minus 1 equals to e minus 2 plus e inverse square equals to e plus e inverse minus 2 e plus e inverse equals to square equal plus 2. So putting this value that we get here is mu square equals to 1 by 4 square plus 2 my plus 1 by 2 equals to square upon 4 plus 1 by 2 plus 1 by 2 equals to square upon 4 plus 1, where mu square equals to 1 plus square upon 4. Then further we go ahead for the next one, that what we'll discuss here. So for the same we go ahead and that what we'll have to discuss here, we'll discuss that these are next of the rest of the questions in the next coming class. That is being the important one, of course, and that what we have to go ahead for the same. So for the same we go ahead further, and that we'll discuss in the next coming classes. So here in the CBNST we go ahead to end up with, but before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. On the cases of other than CBNST, yes, we had done your reasoning. Here we had done verbal reasoning. In that we had done general mental ability and the logic reasoning. In non-verbal reasoning we had done your many of the topics related to it. We had done series and logic, classification, analytical reasoning, meta image, water image, embedded figure, completion of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation, analysis, practice question set, and then after that we had completed that. After talking about that, we are dealing with English vocabulary. We had done sociology and software engineering. We had started with chemistry for class 12th and chemistry for class 11th. Part 1 we had done, and for class 12 part part 1 we had done for chemistry. In that we had done your unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 with the conversions, logarithms and antilogs. After talking about that, we had done your terms of quantitative aptitude, where we had started with arithmetical ability. In that we had done your operations on numbers, SCF and LCF of numbers, decimal fraction, simplification, square root and cube root, problems on numbers, problems on ages, such and indices, percentage and profit and loss that we are dealing. That has been the 11th topic of the sessions here. After completing that, we'll start discussing about ratio and proportion, which has been another important one. In terms of CBNST, we talk about it, that is in the computer-based numerical and statistical technique, where we had done your unit 1. In that we had done computer arithmetic errors, where we in that floating points arithmetic error, that is machine abscon, regular rules of error, chopping and error, truncation error, associative and distributive law of the floating point in arithmetic, inherent error, error propagation, numerical instability. In rules of error, we had done second method, Newton-Raphson method, methods and the fixed point equation method, simple rules and derivations of the rate of the conversions, multiple additive and accelerations of conversions, modified Newton-Raphson method for the multiple rules, White method for the polynomial, Weierstrass method for the quadratic factor, and your computer algorithm of these methods as well. After completing this, we will start discussing about, we had started with unit 2, which is the interpolation and curve fitting. In that we had started with algorithm of the error analysis of the Lagrange and the Newton's divisor differences, interpolation, relationship in the various differences operator, piecewise linear interpolation, cubic spline interpolation, natural spline, Chebyshev's polynomial approximation, Langkow's economization of power series. In curve fitting, we have to cover up the linear and nonlinear least square approximation. Third, conditioning in the least square method, Gram-Schmidt's process of optimization, computer algorithm of least square curve fitting. In unit 3, we have to cover up, that is being the differentiation and integration. We have to cover up the method based on the interpolations and finite differences, Richardson computation, integrations, errors and analysis, trapezoidal and Simpson method, Newton's Course integration method, Gaussian integration method, Gauss-Lagrange method, Lobato integration method, and Radau integration method, error terms in pertaining integration method. In unit 4, we have to cover the solution of simultaneous linear algebraic equation. We have to cover up the Gauss elimination method, conditional system, condition number, successive and referensive methods, and the rate of conversions. In solutions of ordinary differential equation, we have to cover up single step method, Range-Kutta method, that is the third order and the fourth order method, multiple step method, predicator and the corrector method. In statistical techniques, we have to cover up the statistical technique, statistical hypothesis, test of hypothesis, type 1 and type 2, errors, level of significance, test involving the normal distribution that we have to cover up. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.